country, it's my pleasure to welcome you all to the 2022 Innovative Student of the Year Award. So to formally open today's event, I'd like to invite this year's Engineers Ireland President, John Parr, to the stage. Thank you, John.
Good afternoon, ladies and gentlemen, students, parents, judges, and special guests to the 2022 Innovative Student of the Year Award, kindly and very kindly indeed sponsored by Siemens. I think these occasions are absolutely wonderful. They're a showcase of the talent that we have among our young engineering students, soon to be engineers and making an enormous contribution. I'm just reminded, as I said hello to one or two people earlier, that if it was only 50 years ago, and if I was about 10 times more intelligent than I actually am, I might have been able to make it to something close to the shortlist. But unfortunately, my time is gone, but your time is here, and you're very welcome to it. It's the 23rd year of this very successful competition, and most sought after award, which is open to third level engineering students across the island for the opportunity to showcase their engineering innovation and creativity, apply their engineering knowledge, and open the potential to commercialise their projects. Engineers are people who design, create, explore and innovate, working to solve some of the world's greatest challenges, and this award shows how our future engineers are embracing these skills at this early stage of their engineering journey. These are skills you will never fail to use, because as never ever before, we are living through some of the greatest challenges ever faced by man. And it will take engineers to navigate a safe passage for mankind. If you and future engineers don't do it, nobody else can. You all know what these challenges are, and top of the list has to be climate change and all that entails. Clean energy, availability, accessibility, affordability and sustainability. Drought, rising sea levels, mass displacement of people, food shortages, hunger and many, many more. So the challenges are there. Please, I would say to you, don't ever underestimate the contribution you can make and the wonderful primary degrees you will all graduate with shortly. But can I also suggest to you to never be afraid to move outside your own comfort zones, because in doing so, the real value you actually can create will manifest itself at that time. The key difference in this year's competition is how each project aims to embed sustainability and ensure the solutions adopted have the minimum negative impact on the planet. This aligns with our own vision of being a community of creative professionals delivering sustainable solutions for society. The students will show how they've adapted their principle, or this principle, which will be assessed in the pitches they make later. And before I go any further, I want to recognise the support received from Siemens. Siemens have been supporting this student competition since 1999, and remember that was the last millennium, which goes just to show how incredibly dedicated Siemens have been and continue to be in driving innovation in engineering. It's my pleasure to welcome Joe Walsh, General Manager of Siemens Ireland, who is attending today and participating in our adjudication panel, along with his colleague Audrey Anderson. I'd like to wish the very best of luck to each of our finalists representing Atlantic Technological University and Munster Technological University respectively. But you should all be immensely proud of how far you've come in being shortlisted for the final. I expect that there were many long hours and days with some disagreements and frustrations when you didn't get the result you wanted, but nonetheless, you all persevered, and you're now here in front of some of your own peers, friends, family, lecturers, and other students to show what you've done. And never, ever underestimate the invaluable experience and learning those disagreements and frustrations will bring you. I can assure you they won't be your last. Just like your own engineering journey, this is only the beginning, and I hope that each of you make your projects a reality and bring them to the market where the need arises. The panel discussion later from last year's winners of the Student and Graduate Engineer Award will show how you can do that. So during that space, I'd certainly encourage you all to listen very closely. Finally, a word to everyone joining us in person or online. I hope that you enjoy today's event and take inspiration to give that project you're thinking of or currently working on a chance so that you can find a solution that adds value to our society and tackles the challenges I spoke of earlier. The opportunities available both within your institution, which is Engineers Ireland, or with the support of other organisations are endless. And as engineers, we have the duty, and it is a duty, to not only use our skills to keep the world functioning, but also to innovate and make it a better and more sustainable place for all of us. It's my honour as President of Engineers Ireland to open this event, and it's great to have the event in person and supported by the ubiquitous Zoom now, which none of us knew much about until about 2 or 3 years ago, but thankfully is a huge support to us and a lot of others in doing business these days. Again, the best of luck to all contestants and a very heartfelt thanks to Siemens for their continued support. Thank you very much.
So thank you, John. Before we hear from our shortlisted finalists, I would like to introduce you to our adjudication panel this afternoon. Joe Walsh. Joe is the Director and General Manager of Siemens Ireland. He is an authentic leader who brings energy and enthusiasm to all aspects of his career and his private life. He continually strives to empower all he engages with to fulfil their potential. With his industry expertise and market knowledge, Joe's focus is to drive Siemens Limited continued growth and customer satisfaction, paying particular attention on the market for intelligent, adaptive infrastructure required to address the challenges and opportunities of urbanisation and climate change. Siemens is a technology company focused on industry and infrastructure, supplying technologies for more resource-efficient factories, resilient supply chains, smarter buildings and energy grids. By combining the real and digital worlds, Siemens empowers its customers to transform the industries that form the backbone of our economy. Thank you, Joe. Aisling Hassey is a senior structural engineer in the buildings team at Arup, based in Cork. She has solid technical experience and a strong track record on international projects, having worked on a number of complex building and infrastructure projects in Ireland, Canada, the UK, Mexico, Saudi Arabia and Peru, as well as development projects in Rwanda, Uganda and Bangladesh. Aisling completed a 3-year assignment in Arup's Toronto office from 2017 to 2020, where she worked on large transportation projects, including stations, deep underground shafts and maintenance facilities. An advocate for promoting engineering to underrepresented groups, Aisling was a panellist at the first I Wish STEM Showcase in 2015 and organised an ongoing mentoring programme for secondary school students with Business in the Community Ireland. In 2021, Aisling was awarded Engineer of the Year by Engineers Ireland. Thank you for your time, Aisling. Mia Fahey McCarthy. Mia is Head of Sustainability for SSE in Ireland and Northern Ireland and has worked with our company for over 5 years on all aspects of sustainability, incorporating both the environment and social. Mia has a strong passion for social justice issues and recognises the roles which companies can play in supporting a just and fair society. Thank you, Mia. And finally, Barry Bowen. Barry has been a member of Engineers Ireland since he graduated from UCD in 2009 with a Master's in Biosystems Engineering. He manages the engineering team in Morgan McKinley, a specialist Irish-owned engineering recruitment company. And Barry typically works on roles in the manufacturing, medtech, life science sector, as well as senior appointments. Since joining the engineering desk in 2017, Barry has regularly volunteered his time to support engineers coming from overseas and also recent graduates who are entering the jobs markets for the first time. He and his team have helped hundreds of engineers take the first steps in their engineering career. Barry and his colleagues continuously promote Engineers Ireland to candidates and clients they are working with on a daily basis. And Barry supports student and graduate members of Engineers Ireland, leading CV workshops with the Young Engineers Societies. And this is the second year Barry is participating on the adjudication panel for this award. So thank you, Barry. We have had a large number of submissions again this year, and it's great to see the projects that our young engineers are working on, as John mentioned earlier. Although not everybody can be shortlisted, we do thank all of those who did submit projects this year. So our first presentation this afternoon comes from MTU Cork. The team of Sam French, Beverly Jones, Olin Hennessy, Harry Sweetenham, Philip Healy, Niall Marley, Dylan Horgan and Ben Donovan have submitted their project entitled Tunnyrome. I'd like to invite Harry Sweetman and Olin Hennessy to present on behalf of the team. Both Harry and Olin are in 4th year of mechanical engineering. When you finish your presentation, can I ask you to stay at the podium for the judges' questions? Thank you.
Hi all, so my name's Harry and this is Olin, and we're from MTU and we're presenting on behalf of our team Honeyrome. So I myself have been a beekeeper now for over 7 years, and over this time I've learned so much about bees and their benefits to society. I have however seen that there are so many pressing issues which are causing colonies to be lost year round. So without bees, over 50% of fruit and vegetables wouldn't grow because they wouldn't be able to be pollinated, and over 250,000 species of plants would go unpollinated as well. This would decimate global food supplies, causing mass hunger worldwide. Additionally, in the US alone, beekeepers are reporting 40% of bee colonies being lost year on year. This is totally unsustainable, and at the rate it's going, it will see a major decline in bees in the future. To combat this, we have devised a system that will keep track of the bees within the hive, keeping track of the weight, the temperature, humidity, CO2 levels, vibration, live visual feed, and a few other things as well. By doing this, we're able to get a general idea of the size of the colony and how they're doing. But seeing the information is about useful as just seeing it. We're using the information to its full potential, so we plan to be able to change the aspects within the hive. By heating and ventilation, we should be able to heat the bees when they're cool, or heat the bees when they are too cold, or cool them if they're too hot in summer. This will allow for optimum conditions year round, improving brood quality, brood quality, the honey production levels, and also the overall health of the hive. It should also prevent things like the varroa mite, which is causing as well devastating effects to beekeeping societies, as it kills and harms hives. So by heating the temperature, we should be able to eradicate the mites within the hive. So next, Olin will talk a small bit on the innovation of our product.
Okay, so thanks, Harry. So the innovation of our project comes from introducing machine learning and AI into beehives. So by introducing machine learning, we'll be able to see if we can identify any unidentified patterns in bees. And by using this information, we'll be able to see, will we be able to use this to okay. So moving on and using this information in our app and linking it to it, we will be able to share information in real time by connecting beekeepers in chat. So if any beekeeper would have a question or is struggling to mind their beehives, they can put a message into the chat and another beekeeper will be able to answer the question instantly. And for sustainability then, we will be able to use the information and link it out to the app in real time. So by beekeepers able to access information from their apps remotely, they will reduce the need for them to go out and visit their hives. So sometimes beekeepers could be doing upwards of 50 or 100 kilometres round trip, and by saving just even the diesel burnt per beekeeper, that will have a huge effect on greenhouse gases and fuel consumption. And we all know there's a big crisis and prices are high to pumps these days. So for cost shipment and sales, the cost of our bee hives will cost between 22 to €75, depending on the bee hive being produced. So we have a new kit, which is the full beehive, and just a retrofit which will be able to fit to the roof of the hive. And shipment of this will be done through rail systems and container ships through flat pack systems, and that will cost in the region of €7. And then that will enable us to have profit margins of €318 or €221, depending on the kit being sold. So to bring this product to market, we aim to prototype, well, we already have prototyped, and we've shown this prototype off at local markets just to gauge interest from local beekeepers, and we've got a good response off that. So our next step is to get investors so that we can mass produce for the Irish market and UK market, and then move on into the international market once we've sorted all that. So thanks for listening, and any questions?
So, can you hear me?
Yeah.
Harry, just go back a step for a moment. You talked about a figure from US beekeepers.
Yeah, that's right.
Percentage of bees being lost. Do you know why the bees are being lost?
Yeah, so at the moment it's generally from the conditions. So it's either cool weather or swarming. So in large situations in almond farms and such, they can only keep track of so many hives when, like, you're talking like upwards of 10,000 hives on a farm. So to keep track of them, there's an awful lot of work in doing that. So they have to essentially be one step ahead all the time. So if the bees need more space, they have to have predicted that. So we plan by monitoring the weight, we should be able to tell them when they need to add, and even just by doing a sample size of their hives, they should know that that's when they need to increase the size for everyone else. So it's generally swarming, and also not so much in winter, because in America they use it's forced winterization, where they actually climate control the hives in huge settings. But see, our product is actually to do that within each hive. So yeah.
So weather conditions, is that what you said?
Weather conditions and swarming. So
Okay.
Yeah.
Thanks, Harry and Olin. It's a really interesting project. Olin, I just had a question for you around the costings you had there on the previous page, and just with the shipping piece. And I was wondering, just again, to kind of, I suppose, firm up the sustainability element of the project, is there any way that you could go about sourcing your materials within Ireland as opposed to having to ship them from somewhere, or not? Or have you looked into that?
The reason we were sourcing them from China was because there's a very competitive and attractive technology market out there. So we're able to source the components for cheap, ship them over, and then we can assemble them in Ireland or whatever country they're being used in. So it'll create jobs locally as well as support the Chinese market.
Thank you.
No matter.
Well done to you both, and to all the finalists here today. As John mentioned, to get here is an achievement in itself. It's absolutely huge. Just my question relates to the upkeep of the hive itself. So when you're to pass it over to a farmer or to somebody who maybe is not in tune with bees as much as yourself, is that something that you will cover, or is there warranty, or what are your thoughts?
Generally, the beehive, the wooden hive itself, should last in and around 30 years without any like major protection or anything like that. So we plan to generally have the electronics last for the same. So like in terms of servicing, I imagine we'd do the same, like just like at the moment we have it just on an Arduino, but in terms of production we'd probably move to a printed circuit board or something. So just to keep it simpler in that.
Okay, and just on that, so I saw you had a jar of honey on the desk there in the conference room. Who's responsible for harvesting the honey? Is that yourselves?
That's myself, yeah.
And you look after that then? In
Yeah.
terms of, you'll commercialise that?
Yeah.
Very good.
Yeah.
Good stuff.
Hi, Harry. Hi, Olin. Excellent presentation. It's a really, really interesting concept, and it's nice to see that you've done some prototypes as well to understand how it works and the whole system. My question is about the financial viability of this. So in terms of you to retrofit, I'm assuming a standard hive is €250. How much, or have you looked into how much like the average beekeeper would lose a year without a monitoring system?
Yeah, so generally, I'll just say, generally a hive, to replace an actual hive is about €300 is the cost of economy.
Okay.
So like if you're saving one colony, that's essentially paying for your device. So that's the one major benefits. You got anything to add?
Yeah. No, that kind of covers it.
Okay. Excellent. Thank you.
Can I ask you one?
Oh yeah, of course, yeah.
Forgive my ignorance. What do you mean by swarming?
So swarming is essentially when a hive gets too crowded, half or the majority of the bees will want to find somewhere new to live. So what they'll do is, it's very hard to predict, but about 2 weeks before they essentially swarm, they'll start changing. So they'll start making a new queen, and they will stop making as much new eggs, and they'll stop making as much new honey. And then the day they swarm, then they'll probably, or they do, they take all the honey that's in the hive, and they essentially leave the hive and let maybe a quarter of what bees were there to keep the old hive going, and it essentially, usually what's left dies because they're just not strong enough, and the new hive then, if they're early up enough in the year and they find a good enough place to live, then they will be fine, but if they don't, then they generally die as well. So it's essentially their way of making two hives out of one hive, but it rarely, naturally it rarely works out, especially with the weather conditions here, so yeah. Yeah, is that everything? Or? Yeah, perfect, thanks for that.
Thank you, Harry and Nolan. Our next project is from Anya Kane from ATU Galway. Anya is a graduate from Biomedical Engineering from 2002 and is currently working as a quality engineer in Mullingar. She is presenting her project, Endosteel Dental Implants with Cellular Architecture. Again, Anya, can I ask you to stay at the podium when you finish your presentation?
Hi, my name's Anya Kane. I'm a biomedical engineer in ATU Galway. My project is a dental implant with the concept of cellular solids. The main problem is bone loss. Thank you. The main problem is bone loss and that poor fixation and stability, and bone loss, and then this using through computer aided design, I was able to design. I had two concepts where I went with a single piece implant, where this will stop micromotion. I also have a cellular solid for better ingrowth of bone, and I made the implant to the same mechanical properties of that of bone. Using finite element and the Gibson-Ashby equations, I was able to get 3 cellular solids into with the same strength as 20 gigapascals as bone, and this to prevent stress shielding, which is a problem in terms of bone loss. It happens when an implant has a greater strength than that of bone. And then using finite element, I able to get the porosity density and the correct gap width in each cellular solid to allow for bone ingrowth. As this is a medical device, it's a class IIA medical device, so that means it can get 510K loop to get to market, but it doesn't technically approve it. I used a very well-studied biocompatible material, titanium alloy, which can become in powder form, which can be additive manufacture. And I did a business plan, and I'm going to put this to market at €500 to get to a reasonable turnover at the first year. If I was to get to market, I would do further research. I put out a literature review paper, then I would go about getting a design patent. I could either sell the patent, or I could continue with getting 10 to 5% testing, and then get market approval in terms of the 510K loop, and then I'd get a subcontractor to manufacture. I'd like to thank Dr. Dennis O'Mahony and Dr. Oliver Mulrine from ATU Galway. Thank you.
Hi, Anya. Thanks
Hi,
for
how's it
the
going?
really interesting presentation. I'm wondering what you think the challenges are with bringing your product to market when there's various implants on the market already.
I actually think I skipped the slide there, but there is commercialisation, so I don't know whether, now that you say mention that. Sorry, it's just not there. So at the moment, there's only one at the moment. It's called Zimmer Biomet, and it has a very more complex design into it. So it's my design behind this is my implant is very simple, easy manufacturing through additive manufacturing, and it's more complex and it has the same mechanical properties of bone, whereas the one currently at the moment you can't calculate in terms of it's harder to calculate and it can't be easily done through additive manufacturing.
Thank you.
Thanks, Anya. A couple of questions, a double-barreled question, if you don't mind.
Yeah.
I think you said there was only one alternative, Zimmer,
Yeah.
and you said yours was €500. I'm assuming that's €500 per implant?
Yeah. So if I
Okay.
was to want to sell it,
Yeah, that's okay.
in terms of material, it's 0.03 grams. 0.3 grams to make in material.
Okay, so if yours is €500, do you know what the cost of the Zimmer one is?
That's the same.
It's the same.
So I match them, but I'm still
Okay.
coming out at a good profit at the end of the first year if I was going to buy materials and all the costs it costs.
Different cost, but the same
Yeah.
salaries. Okay, thanks.
And so with the product that you have, so your design is based on the bone density of the patient, the
Yeah.
particular patient. How easy is it for the dentist, say for example, to determine what the bone density is? Do they have access to the scans in their practice, or?
Yes, so in this project for my I was able to use medical imaging.
Mhm.
So you're able to extract any information of any person's jawbone, and you'll get their specific needs, so you can actually match, you can create this design around them, and you're able to, in this case for medical imaging, I even got a 3D print of a jaw, but I don't have it with me, but it's very easy to get a specific person's jaw density.
And I presume it would vary depending where the tooth was. So, you know, teeth at back probably might be a bit stronger, bone might be a bit stronger than they would be at front. That's
Yeah.
right. Okay.
Thanks, Anya, and well done on your presentation. Again, I've just two kind of questions, I suppose. Just in terms of the cost, the $500 you have there on screen, I'm
Yeah.
just wondering, did you take into consideration, or is it a consideration, the accessibility of this technology to the wider society? So I don't know what the actual cost would be to the patient in the end, but just in terms of the social sustainability element, and also just in terms of the material piece, did you kind of look at a life cycle assessment? So just those two questions.
Yeah, so the life cycle would probably be one use once you after implanting, so it's with that patient for life. And it's very little material, even taken, because it's a porous material, so you're removing material, so less material than a normal implant and less strength. And then on top of it, it's additive manufacturing, and it's a very easy way, as in it's like 3D printing, there's no waste in materials, so sustainability. And I was doing it over a business plan, so I was trying to make as much profit as I could, and that was with including, but the price of the implant could definitely be lower and be more easy fundable for other people, and just because it's an easier process to manufacture.
Great, thank you.
Thanks.
Sorry, Anya,
Yeah.
another question, if you don't mind. Do you have any idea how many implants are used, whether that's in Ireland or Europe or US?
there is a large market profit. Even people are doing it for cosmetic reasons now, and especially in the last few years. But there's, as you can imagine, everyone goes to the dentist. The amount of people that would have root canals, the missing teeth, I don't know the exact figure, but there is a large market. I think on one of these slides I probably went through it, well, missed it, but there is a large market for dental implants out there. Cheers. Thank you.
Thank you, Anya. So our final project this afternoon is again from MTU Cork. This is a big team project made up of Mary O'Riordan, final year BEng biomedical engineering student, Sean O'Shea, who's currently in his final year in mechanical engineering, Ali Rezke, a final year student of mechanical engineering, Andy Leahy, who's currently studying advanced manufacturing technology, and also involved were Dana Power, Owen McGrath, Joe O'Reilly and Jamie O'Hanlon. So Mary and Sean are going to present their project to LIPA and on behalf of the team, and then for the question and answer session, Andy will also join them.
Good afternoon. My name is Mary O'Riordan. This is my colleague Sean O'Shea. We're final year biomedical and mechanical engineering students in Munster Technological University, and today we'll be introducing our product Tulipa to you. So a device which many women across the globe have become acquainted with in their lives is the speculum. A speculum is a common women's health device used to aid in cervical examinations to retract the vaginal walls and allow a clear view of the cervix. Women across the globe, including myself and my colleague Dana, have said that this duckbill shaped device has inspired high levels of anxiety and embarrassment within us. The mere thought of a speculum is enough to make any woman grimace. Speaking to Dara Philpott, clinic manager in the colposcopy clinic in St Finbarr's Hospital in Cork, she has cited that even women who do attend these crucial exams still face problems such as pinch points as a result of the uneven pressure distribution when opening the speculum. The speculum has also been shown to be ineffective in women of various shapes and sizes, primarily affecting women who may have a higher BMI or who have had multiple pregnancies or deliveries. This is where the vaginal walls might tend to cave in between the two leaves of the speculum, which causes unbearable discomfort for the patient, as well as obstructing the view for the practitioner. Let me give you some startling facts. These issues have such a significant impact on women that 20% of Irish women don't attend their routine cervical exams. This puts them at risk of developing cervical cancer and joining the 500,000 women diagnosed annually with cervical cancer, making it the fourth most common cancer worldwide. Worldwide, cervical cancer accounts for almost 8% of all female cancer deaths. An estimated 311,000 deaths occur annually each year, with 80% of these occurring in low or middle income countries. And there's also a 75% mortality rate in sub-Saharan Africa.
So, what is Tulipa? Tulipa is a modern universal speculum which uses a single-use polyisoprene sleeve, which is exclusive and compatible only to Tulipa. Tulipa has 8 stainless steel legs and is placed over would be an polyisoprene single-use sleeve, which creates a smooth barrier between the speculum and the vaginal walls of the patient. This eliminates as many pinch points and edges as possible, making it more comfortable for the patient. Following our research, we set out to define some design requirements. Firstly, we wanted to make it comfortable during the expanding process for the patient. We want to eliminate as many pinch points and edges as possible. We wanted to have a strong, durable mechanism which will allow equal pressure throughout the vaginal walls. And we would also want it to be a reusable device just with a throwaway element, which would be the polyisoprene sleeve. So here we can see our video of our CAD model and our prototype. So Tulipa is reimagining cervical examinations by making the device as universal as possible in terms of who can use the device comfortably for the patient. So, by 2028, the global market is expected to reach a startling $1.1 billion US. This is a huge potential market for Tulipa. We plan to target general practices and private clinics in Europe through business-to-business strategy. We want to build trust with our customers as well as with our patients. It is a competitive market, but only as far as the single-use speculums are concerned. There are very few businesses that have made such innovation as Tulipa have in recent years, which will affect practitioners' day-to-day work.
We want to tackle women's feelings towards these exams and turn any feelings of embarrassment to empowerment. We are confident that Tulipa can aid claiming back and overcoming a lot of fears and lack of confidence that women have in regard to these exams. By reducing any dread or anxiety that sits in the back of women's minds, the number of women expected to take these cervical exams is going to rise. The device is proposed in order to give every woman a long, healthy life and to take hold of their intimate health in ways they would have had apprehension about before. If you take anything away from our presentation today, please let it be this: cervical cancer is preventable and Tulipa endeavours to prevent it. Thank you very much. We welcome any questions.
Mary, well done.
Thank you.
Would you mind going back on the slides for a moment and showing us the device itself? If I get this correct, the wheel at the end is turned to widen out the 8 stays.
Yeah, exactly.
Did you consider having some sort of that looks to me like it's turned by hand? Did you consider having some sort of battery or something on that it could be?
So this being our first revision and I suppose first proof of concept really, we have been looking into using some technical elements down the line, not at the moment, but definitely even incorporating something like AI and stuff like this, using pH sensors and all this. So battery operated isn't something we've considered, but definitely integrating technology is something we will be looking at down the line.
We have considered the use of air, so there is a comparable process used in practitioners that they'll actually use an airbag as almost a generation device for air pressure. So this is something we have looked at, and it is a possibility that could be used due to the safety aspect of it. If you use batteries or something like that, you're introducing the risk of obviously something not working. So in general, a manual or a process like that might be more sought after.
Thanks, Mary and Sean and team. Really interesting project. And somebody close to me had mentioned previously when they go for their screenings how they were sure that the speculum that was used must have been invented by a man because of the pain they experienced, and you enlightened me that yes it was, and that the only other female idea that came around this was stolen by a man. So I think that's all really interesting to hear. I was just wondering, in terms of, you've made reference to, I suppose, in the developing world and the really high incidence of cervical cancer that are there, and I was just interested to see how you thought you could potentially ensure kind of that this prototype, or what will come from it, could be potentially accessed by other parts of the globe.
Yeah, so I can take that one. So what we were looking at doing is introducing, with our disposable sleeve, that when we would sell 5 boxes of disposable sleeves in the first world, we would donate 1 box to the third world. So even if our Tulipa model didn't make it to the third world, that sleeve that can protect from infection is still there and still can be used on the patient, because the risk of infection and reuse of device in the third world is so common. If we can do anything to help in that regard, we will.
Hi, thank you for that really interesting presentation. It's really, really, long overdue product, I think. A question for use in the developing world. So you mentioned you have a disposable sleeve, and then the base product is going to be stainless steel. Does that need to be sterilised after each use as well?
No, it doesn't. The sleeve that we've developed has enough coverage so that there's actually no way that the patient is actually going to be in contact with the inner device. so it's
Okay.
completely protected.
Okay. So in the developing world, anything that single use can run out, and that you might, after they run out of these sleeves, they might start using it without the sleeves. So maybe just a consideration for how you adapt this prototype for the developing world, and that, you know, is there, I guess, those pinch points that you were talking about, just a consideration for that. But otherwise, I think for the developed world, I think it's a really interesting project.
Thank you.
Yeah, well done. Some of the figures there you have are staggering, and I know I mentioned this to some of my colleagues in the office there the other day, and one of the, I suppose, the general consensus from a lot of people is that they have that fear of going to the doctor and carrying out, you know, smear tests, whatever it might be, and the fact that you've brought this to the fore and people are talking about it, I think is excellent. I just want to go back to just, you had down in the conference room an old, oh, sorry, I wouldn't say old because it's what's still in play, you know, by many doctors. It looks very uncomfortable. Did you look into that in terms of the research behind that, you know, how uncomfortable it is, or, you know, were you able to, I suppose, compare that to your own device?
So I suppose we haven't gotten to any stage where we're close to doing anything like clinical testing, but we have done a lot of personal research. So even starting small, speaking to people like our sisters, our mothers, girlfriends, grannies, people who have experienced the pain and discomfort, the trauma associated with going for these smear tests, as well as looking at actual research that has shown within the last 40 years and hasn't been addressed since, that the traumatization and the fear associated with these cervical exams do push people off actually going for them. So as much as we can't physically test the device yet, we are fairly confident from our simulations that it will work and it will reduce the pressure.
And it looks quite like there doesn't have to be that much pressure.
It's very much a controlled mechanism as well, yeah.
Yeah, okay, very good. Well done.
Thank you.
Thank you.
Thanks very much.
Thanks, Mary and Sean and Andy. So we're at the end of our presentations. So I now invite our adjudication panel to leave the theatre and to begin their deliberations. And I certainly don't envy their task for the next 40 minutes. So whilst they're heading back upstairs to deliberate, they will miss out on the nice piece that we have coming up. So I'd now like to invite Pierre Yumbog, our Community Engagement Executive, to the stage. And Pierre is going to host a panel discussion with two of last year's winners from BioWave and Field of Vision. Thank you, Pierre.
So yeah, good afternoon, everybody. So thank you to all the finalists for their fantastic presentations. So at the moment, actually, we might just have the one finalist, because the other one is actually calling in from China, but Brandon is having some technical issues. But I do have the honor of having Tim Farley. So as I'll let him take a seat, and then I'll do a formal introduction of Tim Farley. So Tim Farley, who's part of Field of Vision, who were the 2021 Innovative Student Engineer of the Year Award winners last year. So you were in this position, it was actually September last year when we had the actual, you had your presentations, but it's great to have you back here. So Tim Farley, he's the co-founder of Field of Vision, where he is helping build handheld touch-based devices to help blind and visually impaired sport fans watch live sport. By utilising portable battery-powered Wi-Fi, enabled Bluetooth and 5G compatible technology to allow the user to experience the events like never before. He also does AI safety research and is currently on a gap year from studying computer engineering at Trinity College Dublin. Also in that team, in that project team last year, and you're still in the same group together, so is also David Danaher, who was also in Trinity College, and Omar Salem from Queen's University Belfast. So very welcome, Tim. It's good to have you here today.
Congrats, I should just say, congrats is what I was saying. Really great project, really great work. It's not easy getting up on the stage. I thankfully didn't have to do it last year, but yeah, really great work, very exciting stuff.
So yes, I guess starting from last year, so yeah, can you give us a bit more in terms of how Field of Vision came about? So obviously, like you were doing it as a college project, I assume. So Or okay, in terms of like, yeah, how did the idea come about? Why? And yeah, how do you even start your group project to then go to the end of the competition?
Yeah, it's a good place to start. So Field of Vision, I guess, started out about 2 years ago. In the early days of COVID, I guess. Because it was a way to keep ourselves occupied. It wasn't my idea. It was my friend Omar. We previously, the three of us, we worked on like school projects in senior school, so we were used to like working on projects together. We got on well as a team. But yeah, anyways, Omar, he came across a video online. Omar and David are big football fans, and yeah, came across a video online basically of like a father and son going to a football game, and the son was blind, and basically the father was helping his son like watch the game by having his son hold out his palm, and the father was like tracing what was happening on the pitch onto his son's palm, just to help him understand like, what was going on. Omar looked into this a bit more. Apparently, like this is common enough. So yeah, he thought there should be like a better way to do this. Apparently, it's still using hands, so he can like build something better, maybe automate it. And yeah, then he hit up myself and David. We worked together before, and yeah, we started working on it. The first like main place where we kind of got together was a program called Patch, Dog Patch Labs, which I really recommend everyone checking it out. You know, we like mid to late teenagers who are interested in working on projects, recommend Patch. So it's like a 6-week program where you just get together and you work on a project. Yeah, that's how we came together. And then we kept going since then.
Perfect. Are you a sports fan yourself, or you were more into the technology?
More into the technology, I guess. Yeah, this is big into golf, but not as much anymore.
Yeah, I guess people question if golf is a sport, but we won't get into that today. So obviously, going back to last year, obviously after you did your the presentations, obviously online last September, and you won the Innovative Student Engineer competition. I'm sure you celebrated and all after that. So what kind of happened next? Where did you go from there to where you are now?
Yeah, so last year, this was September last year. So right about that time, we had been preparing for very like small scale trials in the Siemens football club. We were not with the devices, but just installing our cameras and software. So that was about October last year. We had our like first game in the Siemens football club, and that was just basically testing out the AI software, just the whole software system. So we have to do, we should mention, we have to install cameras into a football pitch to get our device to work. So kind of got that going. And yeah, I guess just to fast forward a bit from there. Kept working on it through the year. Around April this year, we got our first customer. So that was very exciting. With Australian football, somewhat surprisingly, had to go to the other side of the globe to get our first customer, but we got it. We converted our devices to Australian football, and that was our first customer back in like May. And then since then, we're working with them at the moment to try and get that was just for like 1 match or like 2 matches. We're working now on like a more scalable, like full-time solution that will be that we have to be there to get the devices to work. So that's not an ideal solution. I like Dublin, so I want to stay here for a while. Since then we got our second customer. Again, actually not in football, but in motorsport. We got invited to convert our device to motorsport, and we're just back from Japan actually, where we convert our device to motorsport, and we're currently working on. That was just again for like 1 race. And now we're working on like a more scalable. We have to be there as well to exit the process, but maybe it's the devices. But yeah, we're working on a more scalable solution for that. Really excited about the possibility of getting to Formula 1. That'd be really exciting, like tactically. So yeah, we've kept going. We've got customers since then. When I took a gap year this year, working on this full time.
Yeah, actually, on that, so yeah, fantastic in terms of you've gone from, I guess, local sports to all the way down to Australia. I think Aussie rules, I guess, when you're talking about football, the equivalent, I guess, of Gaelic football over there, and then into Formula 1, so that's great. So as you just mentioned there, in terms, you obviously you took the decision just yourself or the group in terms of for you to take the gap year and work on this full time. So how do you come around that decision, and how has it been in terms of running a startup? Like, what's your current day-to-day work like? What's your role in the team, and how has that been for you?
Yeah, so I guess the decision to take a gap year, that was a very late decision. I only made that decision after my exams last year. I guess after I just like had the time to think, I guess it just made sense for me to take a gap year. My main priority at the time was we just had our first
That's very good. So yeah, it's great, and I think it's a good point. Obviously, where he went so far is that he wanted to keep this going and keep this running. So I guess it's good that you're able to take the gap here, and obviously we'll go back in terms of your engineering and what you're currently studying. So obviously you mentioned in terms of you've had some success in terms of like your first customer, and you've gone into you're going into motorsport and Formula One, but I'm sure there's been some challenges along the way. Can you give us a insight to some of the challenges that you face and how you've overcome that, and maybe any other kind of successes that you want to also highlight?
Yeah, there's been loads of challenges. It's just a constant stream of challenges. Like it's even hard to articulate them. It's like everything's kind of challenge. It's what to be perspective. I guess the most salient one in my mind is just I guess one of our strengths as a team was just our naivety and like going into this problem. But it's also one of the biggest challenges. It's a really hard technical problem, and there's only three of us, and we just don't have all the expertise to like get this thing working. I guess one that's like most salient in my mind is like firmware. I'm more skilled at it now, but early in the process, we just had no idea what we were doing. We'd go on to what's it called, like Fiverr, trying to find contractors, and yeah, it's just a really messy process trying to, I guess, outsource your technical work because you're not necessarily at a level where you can like judge how good the work you get is, and down the line that can like fail very fast. So there's been instances where we've like hired someone to do some work for us, get it off them. A couple of weeks later, when we go to like implement it, it just doesn't work, or we speak to somebody who's more knowledgeable about it, and they say this is just really bad. Really bad stuff here. So yeah, just the technical, just trying to cover all the bases. Like it's a really hard challenge, technically speaking. But yeah, we've a good support network. Engineers Ireland, I guess, Dogpatch Labs. There's loads of like tech people in there. You can just have a conversation with someone who can point you in the right direction is really useful. Yeah, the technical problems is all sorry.
Yeah. So obviously the technical stuff. Then how's been managing obviously the entrepreneurial side of like actually running a business? Because obviously I assume you're a company, so you obviously have to like do all the finances and auditing and all that kind of stuff, and manage cash flow. So like, how have you managed that again? Have you had access outside resources, or have you just had to learn Excel and all that kind of management itself?
Yeah, there's been very little cash flow until recently, so that's a new problem. Yeah, and for this, it comes back again just like having a good support network. I'm just learning on the job, like learning fast, like it's the best way to learn anything. Yeah, so just running the business. I guess the product comes first, and then the business will follow after. The product will bring like the business problems that you need to deal with and that like need to be addressed right now. Running a business, it's weird. I hardly ever like think of it as like running a business. It's more so just like product development. Like, this is probably a problem. I should think of it more as a business, but yeah, you have a support network. People you can talk to about making sure you don't get arrested because they haven't paid their taxes, that kind of stuff.
That's important.
Yeah, just kind of. Sorry, this really isn't the most articulate answer, but just deal with it when it comes with it. And I guess get your hands dirty. Like, I much prefer to be coding, but like just earlier, talking about tax forms, just kind of get it done. Get it done.
Yeah, no, that's a good mindset. Obviously, I know it's yeah. Obviously, when you're starting up, obviously you just thought you work on this project and obviously see where it goes, basically, and then from there you're just learning as you go along. So which is pretty good. So obviously, I guess you see yourself in terms of although you're working as on a startup, do you see yourself more as an engineer than as an entrepreneur, and like how do you find like engineering kind of skills you've developed? I know you're still 1 year left to study, but how do you feel that's helped you in terms of where you're at now?
Yeah, there's definitely less of a difference, I think, than like the Venn diagram of like entrepreneur, engineer. They're very much the same thing. Engineers try to build something people want. Entrepreneurs try to sell things people want. And I guess they probably make it too, or bring it to the market. Those overlap a lot. I guess I probably definitely do think of myself more as an engineer. That's just what I inherently enjoy. But I should say the skills from being an engineer also are very useful for like the entrepreneurial side of things. I guess to be specific, like from the engineering degree, I think something engineers are generally pretty good at is like just the way of thinking is you think a lot in like Fermi estimations, so like upper lower bounds or like different things, just making rough estimations on the fly.
Yeah, no, that's good to see. In terms of obviously the engineering knowledge that you've developed, and obviously you're still developing. So I assume you have intentions to finish computing, and then obviously go back to doing this full time. So how you go balance that next year in terms of with final year coming?
Yeah, we'll see how it goes.
No pressure.
I also took like a gap year. I'm not just, or partly why I didn't have the bandwidth this year to do engineering was I'm also doing air safety research. I'll probably I'll probably have to stop that next year to finish the degree. I just want to finish well. We'll see how things go this year though. I didn't know if you taking a gap year well, I guess it was probably actually 6 months ago now. But we'll be going back next year. It is hard to like work on a startup and then also at college. They're pretty demanding, like engineering isn't easy. I guess if you just delegate your time well, you can manage both. It's definitely hard, but like it's very, very doable.
Yeah. I'm sure more capable of it, especially the three of you, and I'm sure, like you said, you have your community and the ecosystem around to support you, so you'll be well taken care of.
Really emphasize like having co-founders. There's no way none of us would have been able to do this by ourselves. Would have been like really hard even if it was just two of us. Three seems to be a bit of a magic number, so that works well. Having a good support network is really, really, really crucial. There'll be weeks where, let's say, David, who's still in college, might have an assignment, he can't do anything, so I can just cut the slack. That's really helpful. Goes a long way. So working in teams is very helpful.
Yeah, that's good. You have a good team working there, because obviously it is going to be times where you all have other priorities or other work to do, but like together you keep up the pace of the work and everything. So in terms of obviously 1 year from now, or I guess 1 year after you graduate and finish your course, where do you see in terms of field of vision? In terms of, are you targeting any kind of specific customers or any kind of sports? Or where do you want to see in the next year or so?
Finally get back to football. We're going to be up north hopefully in March. There's an international match up there. 1 year's time, hopefully we'll have like permanent, like autonomous deployments in like different stadiums. Right now it's just all been kind of like 1 or 2 matches, like one race. But right now we're just really working on making it like a really, I guess, easily deployable solution that doesn't need one of us to just babysit be with the device at all times. So hopefully by next year, we'll be in different sports. Football is a big one. Then Aussie rules and Formula One. Those would be our key ones. What we'd be really keen on and doing is just what we're particularly focusing on is Aussie rules and football. Hopefully have our devices in multiple stadiums by next year. Put a number on it, I guess. 3 would be really good. Working autonomously, we're not there.
No problem. And then obviously that's a year. So do you have ready set down like a 5 or 10 year plan in terms of like, obviously you want to go to every sport, I'm sure. So like in terms of like, where is your next sport after? Is it basketball, golf, like yourself, or where is your like 5 to 10 year? Where do you see field of vision at?
So probably 2 things in mind here. I guess the first is just like which sports will we get into. When we were approached about like converting our device to like motorsport, we were like, no, we can't do this. Just how do you even go about doing that? We thought about it a bit more, and the people who are thankfully kind of egging us on to think about it a bit more. We managed to build something. You'd be surprised, like haptics can be useful for like a lot of different use cases scenarios. Football and Aussie rules, those are pretty obvious. Motorsport, it was less so, but we managed to build or design something. Definitely is a lot more work, but it'll be useful. Maybe golf down the line, we'll see. We want to go into many different sports. Main ones would just be football, Formula One, Aussie rules, and basketball and tennis. Basketball in particular, just how many like goals they are, how fast it is, be really haptically satisfying. So
Very good. And in terms of actually, maybe if probably should start in terms of like, yeah, the actual the device itself. So how kind of work in terms to give a knowledge or an idea for people? How does it kind of work in terms to give it that real life experience of watching a sport, so that they feel like they're also obviously in the stadium, actually in part of the experience and the atmosphere?
Yeah, so I guess there's two components to this. The main one would just be the hardware. So I guess how the device works. To go back to 2 years ago, Omar had a 3D printer at home, and he was very keen on using it a lot. How our device works is it's basically a mini 3D printer inside of a device. So there's a fingerpiece that moves to track the position of balls and vibrating motors that buzz to convey like shots, tackles, passes, etc. So you can imagine like if you're playing Call of Duty on the PlayStation, the remote like buzzes, you get that but with sport. So yeah, we give this device to users, they hold it on their lap. How we get that information to our device is through software, so I guess that's what I do. And we install cameras in the stadium, cameras use AI, extract all the useful information from a football game, Aussie rules game. For F1, we've got like actual raw data feeds, so we can use that with GPSs. Yeah, we send this to our devices through, I guess, 5G. And yeah, that's how it generally works. So it's, I guess, the merging of software and hardware.
That's very good. Just before I move on to maybe a couple of questions, I'm sure the audience probably have some interesting questions. So does anyone have any questions they want to ask yourself, Tim? Anyone at all? No? Damon?
I'm just trying to imagine it from the user perspective. Thank you. So the user has the haptic device. Did you rent that, or did you give it in the stadium, or how does that work?
Yeah, so we sell them directly to a stadium, and then the stadium will sell them. They'll provide them to the user for free on match day. So how it works is we sell, the hardware we sell the devices as a one-off fee to a stadium. They'll buy the devices. Then it's a recurring annual or monthly fee for like the match delivery software. So the software that gets the information to the devices. That's where the bulk of like the markup comes from. But yeah, the main point is that users shouldn't have to pay for this. Or fans, they go to the stadium, they get it for free, as they would like an audio headset or something like that.
Tim, why do you think the Australians saw the opportunity and we didn't see the opportunity here?
I don't know. They think big down there. Like they've got a very much like a builder culture. We've got a builder culture too, but they're kind of like American in their way of like just kind of they're very optimistic. We're very optimistic too, but yeah, I don't know. I guess they were lucky. It's a noisy process finding us.
Thank you for that. So obviously we're here at the innovative student, and you've seen some of the presentations from the finalists here. So obviously being in their shoes last year and where you are at now, like what would be your piece of advice for them to obviously take their project to the next level, and any kind of lessons you learned that you wish you had known, I guess, back then?
Yeah, good question. So I guess going back to like something I said earlier today, was just kind of just try to keep up the momentum, like just keep going. Momentum is really important, especially like think of it in terms of like compounding progress. You do a little bit each day, and it really adds up over time. I guess the key trait to think about there, this word's been on my mind a lot. I'm reading Endurance by Shackleton, where
and then in terms of any kind of practical things, so obviously you mentioned kind of dog patch, so obviously they are kind of an incubation. So like, would you suggest that, like obviously apply for their kind of incubation hub, startup weekends, kind of events, in terms of obviously, yeah, maybe scaling up the idea or getting further funding?
Yeah, good. Thanks for like making it more concrete. Definitely, if you can get to Dog Patch Labs, try to get to Dog Patch Labs. That's kind of like the startup slash engineering kind of epicenter for a lot of things. I'm very biased in saying that, but I think it's true. In your colleges, they might have like an entrepreneurial society. They might have like a sort of like an incubator. Definitely apply if you can. It's a good way to meet people who become part of your support network, and also just helps give you like an extra motivation to keep going. Another thing I recommend, if you might not have like a entrepreneurial society like in your college, is pioneer.app. So it's like a decentralized remote accelerator or incubator. Basically, it's run by Daniel Gross Online. It's a bunch of people working on really cool projects, and each week you kind of post an update of what you're working on. And there's a leaderboard, just basically, which is based on like how much progress you made that week and like how cool whatever you're working on is. And yeah, it's just an extra way to help keep up the motivation and just keep the progress going. So yeah, try find a good like entrepreneurial or like engineering network where you can just help foster and keep the progress going. So yeah, try to get to Talk Match Labs.
No, not plugging them. They're not paying you for this. So and still on that kind of entrepreneurial stuff. So, have you been involved in terms of getting investor or seed funding yet? How's that experience been? Obviously, I know it's probably a bit like this in terms of having to pitch and trying to sell your obviously entrepreneurship is selling yourself as well as your product. But yeah, how's that been an experience, and kind of any tips also for the finalists?
Yeah, I probably don't have as much practical advice here as I'd like to. Right now, we're not actively really raising because that brings its own kind of problems with hiring people. There's a lot of overhead there managing people. It's really hard. So right now we've got money from customers, so we're not trying to raise right now. We're just keeping that going. Once we need to hire people, once it's absolutely necessary, we'll definitely be trying to raise from investors. Probably what's more practically at this stage is like this competition is really great. Like help offer like the financial support to help you keep going. Look for other like grant opportunities. There's Enterprise Ireland. They've got their like student of or entrepreneurial student of the year awards. And there's more. Blackstone Launchpad. Search that up, and that accepts a lot of like startups every year from Ireland. I think it's about 10, and they give you like $5,000 to work on your project, which is really good financial support. You can maybe email like I know a good website which has a good list of like mini grant programs which can really help you along. So keep working on what you're working on, but definitely do prioritize trying to get financial support to help you keep going. We underrated it initially ourselves, but financial support really does help.
And yeah, in terms of, obviously, I know you said the challenge, obviously, you have not yet raising money because then it involves like hiring people. So if you do get to that stage, what would be your first kind of hires? Like, what's your priority kind of hires if you want to obviously continue to scale this idea?
Yeah, the main thing we'd actually be spending money on necessarily, well, probably would be a higher involved, would just be manufacturing. So, Brandon's out in China now getting the PCB the moldings done. That would also be our path, and get the moldings done, making sure we can like manufacture at scale for a relatively cheap price. So that would probably involve hiring someone, as you recommended, thankfully, was just someone on the ground in China can help you with manufacturing. That would definitely be the first priority.
And so you would obviously have the parts manufactured in China, for example, but everything else assembled here in Ireland, or kind of how that operates for you?
Thomas is probably a better person to ask about this. At the moment, he's building absolutely everything from his bedroom. Maybe not the safest, definitely gets the job done and it's cheap. Yeah, I guess moldings, I think we can recommend to go to China, but everything else would be here. Probably myself or Omar putting things together. Yeah.
Perfect. So, and do you have any kind of parts like already? Obviously, I know, yeah, you're working in different sports, but and obviously you still have the Bohemians operation running. Is that for a full year, or is that just a ongoing?
That's ongoing. We actually haven't had our devices in there. It's just been like the cameras and the software. We should be getting in there February/March, I believe.
And in terms of even obviously a part of obviously developing this, obviously you'll have to do certain kind of like customer discovery and like beta testing with customers. So how has that been in terms of what's kind of feedback you've received? Has that fundamentally changed how you've approached the idea in any way, or is it actually what you're building is exactly, obviously ideal word, you want to be building something exactly what they want, but kind of what's the feedback been in that?
User feed or user testing is just really, really, really important. We haven't done enough of it. It's just really important. Like, yeah, I can't stress that enough. That's probably like one of the main things I've learned lately. So yeah, we've done some user testing, gone to like just basically users' homes with a device, just setting up in front of their TV, and we're not using any AR computer vision software. It's just one of us on a laptop beside them. It's like a puppet master within the device. And yeah, what have we learned from them? A lot of like things you just wouldn't expect. Well, things that seem obvious in hindsight. So like some obvious things was, I guess our initial device on the top we've got like, so imagine for football we have our pitch on top. The pitch is textured, but one of the things like the user recommended to us was we had like the pitch embossed in it, but it wasn't like high contrast, it was all like the same color. But a lot of people who are visually impaired will have like a few feet of like good vision. If they had like a high contrast pitch, that would really help. So that's one obvious thing. With motorsport, something we didn't expect was so we don't actually have like an outline of the like racetrack on top. That just won't be the best kind of experience. So we've got like kind of two. We kind of focus on like cars overtaking each other and being able to follow your favorite car as well, the vibrations. But something someone recommended to us was actually having an embossed outline of the pitch below the racetrack on the bottom of the device, which you can't see. Valve apparently really helps people like just visualize the racetrack because they don't really know otherwise, and that can help them kind of place. They're at the U-turn up here, so this is where they are. This is where that U-turn is. So yeah, lots of the features come from users. So yeah, talk to users really important.
And in terms of even at that, like for the sports and for the Formula One or racing, so would you have to go to every single race in order for that, or is it the intention that obviously as to make this more scalable, that the users bring the device themselves, or will it be an element of you joining in with as they flying around the world from all continents doing the racing? So how would that kind of work for you?
It would again be like with the stadiums, we'd sell to them, and then they provide the fans on race day. I wish we could follow each race, but it's not feasible, especially from a business standpoint. So yeah, we'd sell it to them, and by then we'll have just like a device that can work fine by itself. You're remotely operated, but it's really just pretty easy to use by someone at the stand or on the race day. Just charge it overnight, and then give it to fans, it'll be ready to go. Connect it to Wi-Fi. Yeah.
And then obviously in the ideal world, like today, in every situation, you want all the technical stuff to work. So what happens in terms of like aftercare, or just in terms of like any troubleshooting? Will that come from yourself, or is that done by another person?
Yeah, this is something we haven't put enough thought into. Maintenance is going to be a big thing. The devices are very sturdy, but there's going to be breakages. Frankly, this is something we're probably going to work out for us full time. It's probably not really going to be feasible for it to be us, let's say if they're in Australia or in Ireland. So this is something we're going to have to work out. It's definitely going to be a hard problem, but yeah, I don't have anything to say.
No, that's okay. I guess you're still working on it. And probably actually a point I missed earlier on in terms of like the sale to the stadiums or the groups. So obviously in terms of obviously if you want to share how much you sell to them, and if obviously are you selling it per user use, or is it just per depending on the sport? Like how is it that you're pricing yourself and making a margin from it?
Yeah, sure. So for I guess football and Aussie rules, sell each device for I think it's about €600. They cost about 250, 350. Aussie rules will be a bit more expensive. Then I guess where the margin comes from is like the monthly subscription with the match delivery service. So this is different for different stadiums of different sizes, depending on how many matches they have. So up north, they've only got about the football team up north. I think they've only got about 60 matches per year. So that's
No, it's good that you have a different kind of selling the product as well as a subscription fee, and obviously you can obviously factor that in terms of maintenance and other kind of areas of stuff. So yeah, no, fair play. So I think I probably asked enough questions. I've got very good insights. I hope everybody else has in terms of field of vision. It's fantastic concept. Obviously, my question was the last one was whether you're going to go to Qatar, the World Cup in 3 weeks' time. But
Unfortunately not. But, we'll get the next one.
yeah, next one. I think it's in 2026. So obviously there's Euros in 2024 in Germany. So that's a good opportunity also there. But yeah, no, thank you so much, Tim. It's been fantastic speaking to you today. So I really hope everybody enjoyed and online got some insight to field of vision. Obviously, hopefully we'll get you back one day in terms of actually seeing the product itself. Maybe we'll all just go to a football match and see the experience for the users also. So thank you so much for today, and obviously wish you all the best with field of vision and the rest of the team.
Awesome. Thank you.
So now bring back Shirley, and I think this is the key part for everybody in terms of the announcement. So Shirley, back to you.
Thanks so much, Pierre and Tim. Thank you so much for giving of your time today, and I hope Pierre's questioning didn't drill too much into your project, but it's fantastic to hear all the great work that you've done since last year. So we've one more thing to do before we announce the winner. So I'd like to invite our finalists, as I call you up, to the stage to receive your finalist certificate from our President, John Power. And I also invite Joe Walsh, General Manager from Siemens, to join us on the stage for the photos as well. Yeah. So first, the Honey Roam team, Harry Sweetenham and Olin Hennessy from MTU Cork.
No, guys, we've got two lads in the middle and President, a few on the end there, and Joe Lovely. So just come forward to me a little bit here, President, if you can, and come forward a little bit, show us your certificate, turn it around, good man, turn this good man over, and come forward a little bit, lads, out of the projection if you can. That's great. And in nice and tight. Great. Don't fall off the edge. Go back a little bit. Lovely. Great. Here we go. That's great. Hold that there. Lovely. A little bit of projection on your face. We're going to move you back a little bit, okay? Hold on, guys. We'll turn you. There's no point in taking it if it's not taken right. So we'll turn you. Joe, come in there again. Lovely. Good. And in nice and tight. Here we go. That's better. Okay. Hold that there. And again. One more. You might as well enjoy it, right? That's it. Lovely. Good. Nice smile. Well done. Thanks, guys. Thank you.
Thank you, well done. And I would like to invite Anya Kane to the stage from ATU Galway.
Anya, well done. Now we'll turn you this way. Well done, Anya. So Joe, again, come forward to me here like this. President, come forward. Anya, come forward again. That's it. Lovely. And a big smile, Anya. Well done. Oh, just here, everyone. Hold that there. Nice and happy. Good. Happier. Come on. Big smile. Well done. Well done. Thank you.
And finally, the team from Tulipa, Mary O'Riordan, Sean O'Shea and Auntie Leahy. That's okay, Sean and Auntie. All right. Yeah.
Thank you very much. Mary, I'll bring you around. Mary, in beside Joe. Lovely. Good man, Sean. In there again like that. Good man. Pulling it up. Okay, nice and happy, lads. Great. Lovely. Okay. Looking towards me here. Well done. Another one of those. Lovely. Great. Lovely. Good. And Mary, get you lift your head up a tiny bit. There we go. That's great. And again, final one. Well done, guys. Congratulations.
So now we've one more thing to do before we announce the winner, and I'd like to invite Joe to say a few words, and he has the honour of then announcing the winner of today's event. So Joe, thank you.
Thank you, Shirley. So, firstly, just to say that Siemens are delighted to have been sponsoring this with Engineers Ireland. It's been going on for some years and it's really been fantastic. So why do we sponsor it? I've been saying to people that work in Siemens for many years, do I need to speak in here? That business is relatively simple. It doesn't have to be complicated. And the way I say that is, whatever you're delivering, if you get it right technically, you have a chance of making money. If you don't get it right technically, you'll never make money because you'll be going back. You have to do it a second time or maybe a third time. If you make money, well then you can employ people. They buy houses, they start families, they put people through college, they volunteer for Gaelic and hurling and all sorts and everything else in between. So for us, that's sustainability. But bring it back, bring it back, bring it back. It only works if you get it right technically. So in Siemens we say transforming the everyday. Most of the feedback we get around Siemens, most of the feedback is they're good products. That's solid stuff. Good German engineering. That's mostly the sort of feedback we get. So where does it come from? It comes from engineering. It really is that simple. It really is that simple. And where do we get the engineers? Number one, we need all of the colleges. Some of the colleges are here. If we don't have the colleges, we don't have engineers. But beyond that, we need Engineers Ireland to continue their education, to continue their development. So let me just repeat that. Business is not complicated. Business is actually very simple. But it's only sustainable if you get it right. Therefore, we have to have good engineers. So we're delighted to work with Engineers Ireland because that's fundamentally what we're trying to achieve. And it's not just Siemens, of course. It's all of the other engineering companies doing all sorts of infrastructure. So, to the big part. Firstly, thanks to my colleagues who were helping with the judging. To each one of the teams, really fantastic stuff. It's clear and it's obvious that you've put yourself, you've put your heart and you put your soul into it. That's clear and it's obvious and it's really encouraging. So whatever field you go into, you are the engineers of the future, and that's just fantastic. In judging, we came to a conclusion, I suppose, probably faster than in some previous years. And the reason we came to the conclusion we came to was we felt there was a lot of innovation and it was simple and it had a huge potential positive impact, potentially at a global stage. So therefore we said Tulipa were our winners.
If you could come up and receive your winner's certs, and John, I invite you back to the stage as well.
Mary, what I'll do, Mary, I'm going to put you in the centre. Mary, if you come in the centre, we're going to try and keep how much of the projection is. So turn like this for me, Mary. Congratulations, guys. Sean, come in, and Mary. Lovely, come in there again, team. Great. What's your first name again? Sorry. Andy. Andy, sorry, Andy. Come in there. Certs up, lads. Certs up, Sean. Joe, come in on Sean there. Lovely, great. Now, Andy, I'm going to move you until that is not on your head. Come forward a little bit. That's it. Lovely. You're great. John, tuck in there beside Andy. Lovely. You've got one in your head. Can you all see the guys in the back there? Lovely. Come forward a little bit, Mary. Lovely. Okay, Sean, you're just about okay. Go over that way a tiny bit. Perfect. Joe, I'm going to move you as well. Back a little bit, Joe. Perfect. Okay, sorry lads, it's the projection. Okay, here we go. Ready? Congratulations. Smile. Great. Well done. Lovely. Good. Excellent. Well done, everyone. Congratulations.
It's sorry guys. It's probably very unfair of me, but would you like to say a few words?
Look, I suppose thanks very much. This is a massive opportunity for any student, and particularly well done to, I suppose, our classmates, Harry and Olin and Anya. Unbelievable, especially to see another girl coming in on her own, a female engineer. It's massive, and honestly, I respect you so much for it. The judges, thanks very much for engaging with us earlier. It's fantastic. We usually get a good bit of engagement, and to see it from the male cohort as well and see how interested you are, it was brilliant. It was really nice. So, and last but not least, Paul Keane, our supervisor, for driving us on the whole time. Constant motivation. I think, Tim, you were talking about that earlier, having such a good support, a support network. Paul has been our support network from the very start. So thanks very much, Paul. We wouldn't be here without you.
So thank you everybody for joining us both in person and online, and I do hope you all enjoyed the event as much as I did. And of course, more importantly, we will arrange your €1,500 prize in the next few weeks. I don't know how many's on the team and how that will be divided, but anyway, I'll leave you to work that out. But just a note of thanks again to our adjudication panel, Mia, Aisling, Barry, and of course Joe, and to Audrey as well for coming and all your support over the last number of months from Siemens. Of course, events like today don't happen without the hard work and dedication of a number of the team here in Engineers Ireland. Richard and Darren for participating in the shortlist, two of our noted engineers on the team here, to Lucy and to Nosa, and of course a particular mention to Pierre, who managed this whole event, and I'm sure you'll agree did a wonderful job. So thank you all. For those of you who joined us online today, thank you for joining us also. This event is now closed, and I thank you all very much.